Sir, can you see it properly?
Yes. यस लास्ट हम 3 टॉपिक डिस्कस कर चुके हैं, केमिकल काइनेटिक्स, जीओसी, कोऑर्डिनेशन. यस ना?
हाँ हाँ हाँ. केमिकल इक्विलिब्रियम.
केमिकल इक्विलिब्रियम, इलेक्ट्रो. Yeah, let me start the first basic application of electrochemistry or chemical equilibrium.
Sir, electrochemistry is the study of reaction or chemical reaction processes where the movement of electron links us with the electrochemical studies of a chemical reaction. In this case, we are more interested about the energies or the conversion of energies through many electrochemical processes. And in equilibrium, chemical equilibrium, we are saying that chemical equilibrium is a state where in a chemical reaction, the forward rate of reaction and the backward rate of reaction equals. When the forward rate of reaction and backward rate of reaction equals and the change in concentration of the reactant becomes constant, then the state is called as ionic equilibrium. And every reaction which is highly which has high rate constant or anything follows chemical equilibrium condition, and most of the cases we see that a reaction which is very fast reaction or irreversible reaction, those reaction, although those reaction are very fast and one irreversible, they will stays in some for very small amount in chemical equilibrium. So chemical equilibrium is a very important part to study a reaction, how the direction of a reaction acts in a chemical reaction throughout the process.
Yes, good. What are the uses in human life, our society, of chemical equilibrium and electrochemistry? Is explained.
Sir, equilibrium means no change with time. So according to many things, as you can take many examples in case of that, like a fan. Fan is rotating with the same speed. If the fan is rotating with the same speed and doesn't change its speed throughout the time, then we will call it as the fan is in equilibrium. Like our body has a certain temperature and always try to keep the same throughout our whole life. So that means that our body is in a equilibrium condition. And also in case of, on the other hand, in case of electrochemical reaction or electrochemistry is the study of chemical reaction and more interested about the energies. So we can see some application in our real life from the electrochemistry, like photovoltaic cell, fuel cell, and the batteries which are used heavily in our social life, and also biological part of electrochemistry. These are the proper application of electrochemistry in our regular life.
Yes, good. Next is what the application of electrode, calomel electrode, reference electrode. What the main purpose of these one? What the application, purpose, uses? Explain one by one in electrochemistry.
So, sir, in electrochemistry, we are heavily interested in the cell potential, and to get a cell potential, we have to use electrode. And when a electrode we use, then we make an half cell of it. The electrode is basically a metal rod which dipped in a metal salt, of that metal salt which is used in the making of the electrode, that is dipped in a solution, and by after dipping in a solution, some potential difference are begin to emerge, and then if we attach or make the electrode connected, two electrode connected, then we'll make a cell, electrochemical cell. So when we make a electrochemical cells are two types, galvanic cell and electrolytic cell. So in case of electrolytic cell, we are we are converting electrical energy to chemical energy, and in galvanic cell we are converting chemical energy to electrical energy. So in this case, for electrode or the total electrochemical cell, to ultimately get the final cell potential or electromotive force or EMF of a cell, we have to use one standard hydrogen electrode and another reference electrode, by which standard hydrogen electrode is taken as the cell potential is 0, and the reference electrode had some certain cell potential. So by using the electrode and the hydrogen electrode or reference electrode, we make a proper electrochemical cell to run electrochemical process. This is the application of reference electrode. And the reference electrode, if you ask me the example for reference electrode, that will be calomel electrode, glass electrode, and queen hydron electrode. These are the application of calomel reference electrode.
Yes, good. Next is galvanic cell. Galvanic cell या Daniel cell. What the main application and uses in electrochemistry?
Sir, galvanic cell basically converts the chemical energy to electrical energy. So in this case, in Daniel cell is a example of a galvanic cell. In Daniel cell, we use anode and cathode. So to make a half cell of Daniel cell, we use zinc rod and ZnSO4 solution, and also copper rod and copper sulfate solution. And both the electrodes are connected through wire and salt bridge. So when we connected the cell and create a full circuit, then it will show a cell potential. So then when it show a cell potential, we can see the full reaction take place in Daniel cell. So this is the full reaction of Daniel cell, which follows in a galvanic cell and create some energy, and the energy is shown in the voltmeter, or it is shown by the cell potential. Then this cell potential can be used as an energy source, like lighting a bulb. Lighting a bulb can be used for, or the energy source, as a energy source we can use a Daniel cell and light a bulb. So this is how we can make a bigger electrolytic cell, bigger galvanic cell or Daniel cell, which can provide a more significant amount of energy, which can be used to produce, or it can be used to chemical plant or industry for a production type processes.
Yes. What the function of salt bridge? What is salt bridge? What the main application of salt bridge? What the function of salt bridge? Which type of metal used in salt bridge?
Okay. So salt bridge is a U-tube-like structure. This looks like this. It contains a paste of polysaccharide plus an inert electrolyte. Paste of polysaccharide and inert electrolyte. So in case of salt bridge, we use inert electrolyte, and the constituting ions of the inert electrolyte should have the same ionic mobility. Like we can use KNO3, NH4NO3, KCl, etc. These can be used as a inert electrolyte for the making of salt bridge. So salt bridge is basically a mixture of a jelly structure of agar-agar or paste of polysaccharide plus inert electrolyte. This is used to connect two hub cell in a electrochemical cell. So when we add the salt bridge to two hub cell, then the full circuit is created. So then if you ask me what is the function of salt bridge, then first point will be bringing the electroneutrality. Salt bridge brings the electroneutrality which propitiate the final reaction of a Daniell cell or electrochemical cell. And also secondly, it reduces the liquid junction potential. What is liquid junction potential? Liquid junction potential is the difference in potential which creates in a electrochemical cell when when two electrodes are connected through wire, and the electricity and the current electricity has been started. Then if a part of an electrode, if the two electrodes are not connected through a type of this thing like YouTube, then the potential difference between two electronic hub cell will be much bigger, and it will surely stops the reaction when the whenever we will not use the salt bridge. So this is how salt bridge reduces the liquid junction potential of electrochemical cell and also brings the electroneutrality to the electrochemical solution.
Yes, good. What is electrochemical series? What the main application of electrochemical series in electrochemistry? What the purpose
So
of?
sir, in case of electrochemical cell, we have seen the zinc electrode which produces zinc 2 plus and 2 electron, and also in case of anode of the Daniell cell, we have seen copper 2 plus takes 2 electrons and converts to the copper. So this de-electronation and electronation, like to take the electron or to release the electron, there is a tendency of it, and we have to measure the tendency of the de-electronation and electronation between the metals. And electrochemical series is a proper depiction of the tendency of this metal, tendency of the electronation and de-electronation of metal. What electrochemical series shows us that there is a list of metals So this is the electrochemical series by which we can see the tendency of electronation and de-electronation of metal and non-metal by a proper value. So how we can measure? We can measure it by a magnitude, and the magnitude is called as the electroreduction potential. So what is electroreduction potential? In this case, where zinc is converting itself to Zn2 plus, then the potential emerges in the solution will be called as the oxidation potential, and this reaction shows the difference in potential of the emerging and the potential difference emerge in the solution then it will be called as the reduction potential, because here reduction is occurring and here oxidation is occurring. So by IUPAC, it is standardizedly taken as the reduction potential to measure the electronation and de-electronation of electrochemical series. So we take standard reduction potential of these metals and non-metals to know how reactive a metal is or a non-metal is, and to know that the oxidation power and reduction power of this metal and non-metal will be how much extent in how much extent. This will be told by the electrochemical series, and this is the main application of electrochemical series, by which we know how if a reaction is feasible or not. If we take a certain metal, how much reactive the metal is, or if we take two metals, and then we have to know who can reduce who. So this type of concepts or theory can be known from the electrochemical series.
Yes, why is hydrogen electron potential value is 0? What the reason? Explain.
Sir, it is not actually 0. For the electrochemical series, we have to take a standard value by which we can compare the other metals and non-metals for the case of electroreduction potential. So in case of this, we take the reduction potential of hydrogen is 0 to compare the other non-metals and metals. So in this case, the left side metals have negative reduction potential and the left side has positive reduction potential. So by my electrochemical series, it is like this, going like this, from negative to positive. So from we take every value as reduction potential. So this is reduction potential ERP, negative to positive. Whenever the series is going from the top to bottom, the reduction potential or the reduction power of the element decreases. If ERP increases, then the reduction power will be decreases, and if the oxidation potential or OP will increase, then the oxidative power will increase. So by this electrochemical series, we also know how will be the reductive power and oxidative power of an element.
Yes, good. What the difference between electrode potential and standard electrode potential?
Sir, if we take a solution of a metal salt, let's say zinc sulfate, we take zinc sulfate, and we take a rod of zinc. So dipping the rod of zinc in the ZnSO4 solution, then we will see that zinc will started to become Zn2 plus and coming to the solution, and there is a potential difference is emerges here. This is why Zn is converting itself to Zn2 plus 2 electron. So in this case, we will be call it as electrode potential. But when we will use this at a standard state, like 25 degree centigrade, 1 atom pressure and 1 molar ZnSO4, then the potential difference will be called as standard reduction potential or standard electrode potential.
Yes, good. Next is notification. What the main application of notification? What the main purpose of notification in electrochemistry? Explain.
Okay, sir. So Nernst equation is an equation which can give us the cell potential of a electrochemical cell, in which from Nernst we get the equation which is looking like this. This is Nernst equation. From the Nernst equation, we can get the EMF value of a cell, which further can be used as the reactivity of a cell, or it can be used to guess the actual we can get the actual idea to study a electrochemical cell, that how it will react or how much will be the reactivity of the electrochemical cell, or how much it will give us the energy, or how much it takes the energy for a electrochemical cell. So this can be known from the Nernst equation.
Yes, what the drawback or limitation of Nernst equation?
Sir, Nernst equation constitutes of the product ratio, product reactant ratio with a logarithmic scale, and it will surely see or collect the value of EMF of a cell. So it doesn't contains uh, information in itself. So it cannot say the amount or weight of metal deposition occurs in an electrochemical cell, and also it cannot always tells us that how much the value of a to get the actual idea of electrode reduction potential. We cannot get it from here. This is a mere equation which can formulate the EMF value of a cell.
Yes. Yes, how to determine of E cell, and how to determine of del G, del H entropy from Arrhenius equation.
Okay, sir. So in a process, if we take the Gibbs free energy change, then we know the formula, which is del G equals to del G0 RT ln QC. This can be give us the value of del G0, or the del G0 is the basically the standard Gibbs free energy for an equation where the reaction is in equilibrium. So from this equation we can get the value of del G, and as we know from thermodynamics that del G is equals to del H minus T del S. So from this equation we can get the value of enthalpy also. And in another case, we know the equation which is del G equals to NFE0. From this equation we also can get the value of del G, and by putting the value of del G in the equation, we can get the value of E0 cell also, where it is RT ln K by NF. zero cell, and also ln k will be nf k0 by RT, and okay, this is the final reaction, final equation. This is the final equation where we can get the equilibrium constant value, we can get the enthalpy, we can get the Gibbs free energy.
And next is determine the equilibrium constant, pH, solubility product. Explain one by one. What the formula of these one? From pH, from next equation.
सर यहाँ पे के इक्विलिब्रियम का डिटर्मिनेशन का फॉर्मूला मैंने लिख दिया है.
Yes. 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 NFE open RT.
So what is solubility? Solubility is the number of moles of solute can be soluble in 1 liter solution. So this is denoted by S, and when we count the solubility product, which is KSP, then if we take a reaction, solubility of A and B are S. So the solubility product will be A plus, concentration of A plus into concentration of B plus, B minus, and the solubility is S for both. The final solubility will be this. KSP equals to S square. By this equation, we can get the value of solubility product. This is basically the product of the solubility of particular ion in the constructing electrolyte. So if we take an electrolyte which is AgCl, then it will dissociate to Ag plus and Cl minus. And let's take the solubility of Ag is S and Cl is S. So the solubility product will be Ksp equal to S square in this case.
Yes, good. Yes, how many type of galvanic cell? What the example of galvanic cell?
Sir, galvanic cell, the example for galvanic cell will be Daniel cell. And galvanic cell, the work in a galvanic cell is basically converting the chemical energy to electrical energy. This is this process is taking place in galvanic cell, and also in case of electrolytic cell, the opposite conversion occurs there. Their electrical energy converted to the chemical energy.
Yes, galvanic cell is a three types: primary, secondary, and fuel cell. First, primary is dry cell. Explain.
Okay, sir. So, in case of primary cell, primary galvanic cell, we know the example of a primary cell is battery, and batteries are called as dry cell because no solution based things are present in the battery, and battery is quite dry itself, so this is why it is called dry cell. And when we use dry cell shows us the irreversible reaction. What it means that in case of primary cell, the amount of concentration or the amount of reactant can be converted to the product once. Whenever the reaction completes or the reaction goes to the completion, it cannot be used further. So then it will be called as primary galvanic cell. So now if you ask me what is secondary galvanic cell, secondary galvanic cell is a galvanic cell where reversible reaction takes place. Here reversible reaction takes place. So in case of secondary galvanic cell, we have to use the example of lithium cadmium battery, or the battery which is used for the inverters, inverter battery. So this type of batteries are the example of secondary galvanic cell, in which the inverter, we have seen the equation Pb plus PbO2, sorry, Pb plus PbSO4. So this is the reaction which takes place in the lead battery, which are basically the inverter battery. So in this case, lead is used as anode and PbO2 is used as cathode. So in the reaction where charging occurs, then the forward reaction is taking place, and the discharging, if have to use it further, and charging, two types of process is occurring in this cell. So at the charging, the forward reaction take place, and for the discharging, the reverse reaction taking place. So these are the brief concept about secondary galvanic cell and primary galvanic cell we can see in our daily life.
Yes, next is what the drawback. Drawback and limitation of electrochemistry and all cells. Explain 5-10 point.
Okay, so sir, the drawback for the electrochemical cell, like the primary galvanic cell, is this can be used only once, and we cannot use this primary cell again and again in such like secondary galvanic cell. Secondary galvanic cell has a reversible reaction which can be used for a long time, but in primary cell, once the reactant fully goes to the completion of the reaction, then uh, the battery or then the cell, primary galvanic cell, is getting completely useless. So these are the limitation for primary galvanic cell. And in case of electrochemistry, we will see some chemical wastage from the electrochemical cell or the components used in electrochemical cell, which are somehow harmful in our nature. And when a battery or something or any cell is getting rotten or unusable, then we will throw it to the nature, and that will be somehow harmful for our nature. So this will be the limitation for electrochemistry in our daily life.
Yes, next move on. Chemical equilibrium. Yes, no?
Yes, yes.
What the main application of chemical equilibriums? And what is equilibrium?
Sir, so chemical equilibrium is a state of a chemical reaction. So when the concentration change of the reactant becomes constant in a reaction, and the rate of forward reaction and the rate of backward reaction get equalized, then the state of the reaction is called as chemical equilibrium state. So if you have to understand what is chemical equilibrium, then I will show you a reaction. So if I take a weak electrolyte like acetic acid and put it to the water, then it will show this reaction. Firstly, let's say we have 10 molecules of CH3COH in the water. Then the dissociation starts. So the dissociation, after starting the dissociation, when the dissociation is completely stopped, or like the concentration of CH3CO minus and H plus and the concentration of CH3COH is getting the change of concentration is getting stopped, then we will call it as the equilibrium position. So let's say now 8 molecules of CH3COH is present and 2 molecules of CH3COO minus and H plus has been dissociated, and then 7, 3, 3, 6, 4, 4. So now after some time we are seeing that the number of molecules of CH3COOH is getting 6 and it stopped here, and also the number of molecules which are CH3COOO minus and H plus is 4 and 4. This is also same and it is not changing. So then we will call it as the equilibrium position, because in this case the change in concentration of the reactant or product is getting same. So this is the equilibrium position. So this equilibrium position can be anywhere, not the case when the CH3COOH will be 5 and the COO minus and H plus will be 5. This can be present at any of this situation whenever the change in concentration of reactant and product getting